Welcome back in our channel. Today we have two examples how to solve the exact differential equation. And this video will be the last video for the first order. In the next video we will have the second order. The first example, this is equation 1. So we try to find if the partial of m with respect to y equal the partial of n with respect to x, and here they are not equal. So we will find integrating factor to multiply the equation by this factor and see if the new partial m with respect to x to y equal the partial of n with respect to x. And this integrating factor will be either function of x only or y only. We write it as I of x and y, but one of them. Of course, there is an integrating factor function of x and y, but it's not in this video. This is not our subject today. So here our solution. They are not equal, so this is the integrand e to the integral of g of x dx, and here g of x. This one, if we are trying to find I is function of x only. If we are trying to find I function of y only, we put here m, not n, and the same formula. So here we found I equal e to the power x cubed. We multiply our equation by this factor and see if partial of m, the new one, the new m, partial of m with respect to y equals the new partial of n with respect to x, and here they are equal. So our equation is exact. How to solve it? The same way in the last video here. Okay. And then we have partial of phi with respect to x equal m. So here m equal this one. So here dx, here dx. Okay? Now we integrate both sides with respect to x. Here dx and here dx. Integrating with respect to x, and then we find phi, and instead of constant of integration, we add function of y, h of y. This is the constant of integration. Differentiating with respect to y and equating to n. Here. So h of y becomes h prime, and then we found h prime equals 0, integrate with respect to x, we found h of x equals c1. Sub h of x in equation 2, here, in equation 2, then we found phi of x and y equal this equation, plus c1, and here our c, if you remember, phi, the original level curve equation, here equals c, and here k equals c minus c1. So the other choice, partial of phi with respect to y, partial of phi with respect to y equal n. Again, we integrate, this time we integrate with respect to y. Integrating with respect to y, and then we add constant of integration f of x instead of c, because we are integrating with respect to y, so our constant of integration will be function of x. Differentiating with respect to x and equating to m here. So we found this is that f prime of x equal minus x squared e to the power x cubed. And here we found f of x equal minus third e to the power x cubed plus c1. Sub in equation 1 here in this equation. So here our phi of x equal, then from this we find y equal this. So this is the answer, the same as the last one here, same as the last one. The second example here, again, we took the partial of n with respect to y doesn't equal partial of n with respect to x, so they are not equal. So we try to find integrating factor function of x. By the way, sometimes even if we find it either of one function of x or y doesn't work, so we will go with the best one. And here we found g of x equal 1, then I equal e to the integral of 1 times dx. And here, our integrating factor equal e to the power x. We multiply the equation 1 or the original equation by this integrating factor to then here. So now we try with our new m and our new n and see if they are equal or not after multiplying by the integrated factor, and they are equal. See, they are equal. So we made our exact differential equation exact. Partial of m equal partial of, and again this is the equation. We integrate first, the first one we integrate with respect to x. Exactly the same way as in the first example. Then when we add a function of y, h of y, as a constant of integration, because we are integrating with respect to x, equating to n, then we find h prime of y equals 0. We integrate this with respect to dx, same with respect to dy, and here dy. We just got h of y equal c1. We sub in equation 1. Then this is we use the quadratic formula to find y. It's from algebra, which is y equal minus b squared plus minus root square of b squared minus 4ac over 2a. Just you find it in algebra. Now this is our solution. This is our y. The second choice, we partial of phi with respect to y. Again, we integrate, and this time with respect to y. And here we add the constant of integration, this time function of x, because we are integrating with respect to y and equating to m. So f prime of x equals 0, then f of x equals c1. We sub in equation 1 here in this equation the value of f of x, and this here is the answer. Y equal the same answer as before. See, so we insert this is cancelled, the 2 cancel this one, and if we put e to the power x inside the root square, it will be e to the power 2x. Thank you for watching my video, and in the next video we will talk about the second order. So this video was the last video for the first order ordinary differential equation. In the next video, we will have the second order ordinary differential equation. Thank you for watching my video, and please subscribe to my channel, give me your likes, and see you in the next video.